A thin rod of length L equal to 2.7 meter and negligible mass that can pivot about one end to rotate in a vertical circle. A heavy ball of mass m equal to 9.1 kg is attached to the other end. The rod is pulled aside to an angle theta equal to 13 degrees and released with initial velocity v0 equal to 0. What is the speed of the ball at the lowest point? B. Does the speed increase, decrease, or remain same if the mass is increased? So to solve this question, we will be analyzing the energy the heavy ball has at the two positions, that is the 13 mark and the lowest point. So let's sketch the same. Okay, maybe I can use the same figure. If you look at the 13 degree mark or the theta degree mark, I can call this point B and I'll call this point A. I'll call this point O. If you draw a horizontal line from B, you would see that point B has a relative height h. This height is the height of B with respect to A. So with respect to point A, point B has potential energy. But since VB, remember, VB is V0, which is 0, the initial velocity of the release. It was released with an initial velocity of 0, so that's 0. The only energy the ball has at point B is potential. So I can say EB is mgh, where h is the relative height of B with respect to A. Now, how do we find this height? We can see from triangle OB, let me call this C, OBC, we have a right angle here. This rod has a length of L, so we can find the distance from OC. So I can say cosine theta, whatever theta is, well, it's theta not here, is the length OC over L, because this is the adjacent side of the triangle over the hypotenuse, right? Now I can solve for OC, right? So it implies that OC is equal to L cosine theta naught. And what is the height h? If you look at the diagram, therefore, h is the length OA minus OC, right? And OA, since this is describing a circular arc, OA is also L, because L is the radius of this circular arc. So this has to be L2, the radius. So we would have h is equal to what? L minus L cosine theta naught, which will give me L into 1 minus cosine theta naught. Therefore, in conclusion, we have EB, the energy at point B, which is a potential energy, is mgh, which is L bracket 1 minus cosine theta naught. Now we need to analyze the energy the ball has at point A. Now this is all for point B. Let me just put it here, point B analysis. Now we have point A. Now point A has h equal to 0, the relative height of A with the lowest point, because A is itself the lowest point, so it has a height of 0 from with respect to itself. But the velocity is what we are asked to find. We don't know what it is. Since it has a height of 0, it does not have a potential energy, but it has a velocity, so it has kinetic energy. So energy of point A is so absolutely kinetic energy. So we have equation 1, which is energy at B, equation 2, which is energy at A. Law of conservation of energy says energy at B is equal to energy at A. This is conservation of energy. Conservation of energy. Energy is neither created nor destroyed. It is only transformed from one form to the other. So by so doing, we have 1 over 2 mv squared is equal to mgh 1 minus cosine theta naught, right? Now m cancels m. We can multiply both sides by 2, so we have v squared is equal to 2gh 1 minus cosine theta naught. Now we can take the square root of both sides and we get v is square root of 2gh 1 minus cosine theta. Here we can see actually it's mgl, so this is L. Sorry for the mistake. Yeah, look at equation 1 is mgl, so this is L. So this is equation 3. So now this is the general formula for finding the velocity at the lowest point when a simple pendulum or a rod with negligible mass with a ball attached to the end is swung at an angle theta. Now for this specific question, theta is 13 degrees and the length is 2.7. We don't need the mass, so we are going to substitute theta naught is equal to 13 degrees and L is 2.70 meters. Therefore, we saw V is square root of 2 times 9.81 times 2.7 bracket 1 minus cosine 13. I will punch this out. This gives us a velocity of 1.165 meters per second. Now, this is the solution for question A. Question B is asking if the speed is gonna increase, decrease, or remain the same if the mass changes or is increased. Now, just look at equation 3. Equation 3 gives us the velocity of the lowest point and is independent of mass. So whatever mass does will not affect the velocity. If mass increases or decreases, this velocity remains the same. Therefore, velocity or speed remains the same with an increase in the mass of the ball. Thanks for watching.